everyone, what's up? I hope that everything is good in this lovely morning. And this talk will be about Terraform practices to enable infrastructure scaling. Terraform is a great tool, right? It is used widely across the world. And this talk will cover not only bits and pieces regarding Terraform practices, but also hopefully will make you think about Terraform in a broader context rather than just an infrastructure as code tool. So you will be able to enable infrastructure scaling and your team scaling that uses Terraform. So first of all, hi, my name is Hila. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. Recently, I have joined the AWS Community Builders program. I help organize conferences in Israel, where I live, DevOps Days Tel Aviv, and Statcraft Monitoring Conference. I'm a mentor in courses and communities. I co-manage a Facebook community called Pull Request for Open Source, and also lead a program in a community for technical women in tech. I'm a DevOps culture fan. I think this is what helps companies achieve great things. And I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so Terraform implementations could be good, bad, and sometimes even ugly if you use it in a wrong way. And some disclaimers, I show mostly examples from the AWS provider, but of course Terraform works with all cloud providers out there. And I used Terraform open source, so probably cloud or enterprise covers and implements things in different way, but just bear that in mind. Okay, so quick wins. When I say quick wins, I mean low effort, high value things that will help you scale better and more efficiently and prevent refactoring and extra work later on. So first of all, versions lock. So the same as you have with packages JSON lock and requirements.txt for Python, also Terraform allows you to lock versions for modules, providers, and Terraform versions, like you can see in this example. And you can see from this meme by Anton Babenko that sometimes Terraform AWS providers has issues. So just in order to deal with the devil that you know, it's best to lock your versions and just cope with the things that you already know about this version as opposed to need to deal with the unknown, right? So always try to lock versions for modules, providers, and Terraform itself. The bad thing would be to lock the versions but still allow breaking changes to occur, because if you break to a minor version as opposed to major, then breaking changes can still happen, so try to avoid that. And the ugly thing is to have no versions lock whatsoever. Trust me, you'll have syntax issues. You don't want to deal with that. The next thing is tagging resources. So we have the ability to tag resources. It's good to tag them to allow filter and manage your cloud provider expenses and to gain visibility on ownership and overall projects by tagging according to a logical breakdown. And also, if you tag resources, your FinOps team will definitely appreciate that. And if you don't have a FinOps team in your company, congratulations, you are the FinOps team. So just make sure that you tag your resources, because it will help you in the long run and as much as you scale up. These are examples of some tags that we use in Wix for tagging the resources. And also in the AWS provider, you have the ability to set up default tags, which means that every resources that you create under this provider will automatically get these tags. That way you reduce code repeatability, which is awesome. So the good thing is to tag everything that you can, use default tags as much as possible, and you can set up PR enforcement that if someone adds code that has no tags defined, then PR merge will fail. And I'm gonna cover PR and practices enforcement later on. The bad thing is to tag inconsistently, because as we know, consistency is key. And the other thing is to do no tagging whatsoever. It will be very hard to scale that way and to track costs and basically to know which resources belongs to which projects and teams. The last thing in the quick win section is remote state. So by default, Terraform works with local state, and remote state helps you to scale your team because you have one source of truth and everything is remote, right? So this is an example for set up the Terraform state in S3 bucket. And the good thing is to have your state remote and secured, to have it backed up because you can enable versioning on S3, to have a Terraform state lock when you run Terraform apply. You can do it with a DynamoDB, for example. And the bad and the ugly are basically the opposite. So to have local state, the state is remote but not secured or backed up. And if the state doesn't get locked during Terraform apply, then you will have conflicts when you run Terraform. Okay, so we talked about quick wins, things that you can do in a matter of minutes to help you scale better and reduce code repeatability and refactoring. Second nature are basically day-to-day awareness that will help you reduce refactoring code in the long run and prevent time waste and basically align to best practices either of your company or best practices in general regarding Terraform. So let's see. Community models. So there's a saying, right? Why reinvent the wheel? There are a lot of well-known cloud providers features that are already covered by models. So check available models before you implement yours. And the thing about community models that they are approved over time, they are supported by the community, and you eliminate the need to support it and keep it up to date because they do it for you. And also practices enforcement, like checks to make sure that the code is in a high quality state, are mostly done in community models as well to make sure people push code in a high quality state, so we can always take advantage of that. So the good thing is to use verified community models. When I say verified, lately there was the models on the Terraform registry and they had the verified label, but HashiCorp recently removed that label, so you can just look at the number of downloads, and if a lot of users downloaded, probably it's a good and reliable module. The bad thing is to have custom module of your own, but if you still maintain it as such with practices enforcement set up and code the best practices, clean code and stuff like that, if you still maintain it, then it's still quite okay. And to have community module set up without version lock, it's still, as I mentioned before, it could be quite messy. And the ugly thing is to have custom, modules without maintaining it. You will get drift. You will have a lot of issues in the long run maintaining it. And to use unverified community models, because then it will potentially introduce malicious configuration in your code. And if you do have to create your own modules, then make sure you make them stateless and clean. Keep them as generic as possible. Do not repeat yourself if you don't have to. Keep the code as simple as possible, and set up enforcements to maintain quality. I know I mentioned it quite a bit during this presentation, and I do a build-up, but trust me, it's worth it. Okay, variables and locals. So unlike variable values, local values can use dynamic expressions and resource arguments, and locals do not change their values during or between Terraform runs. So this is an example. You can set up variables like projects and environments, and then merge them with other required tags to have like a final definition of tags, and then it will get used in the entire code. So this is only an example, but local is much more complex, and you can achieve other things with it. So on the module side, variables are there to set up definitions for the module configurations. And when you use variables, make sure you set up default or validation, because if not, then when people will try to use that module and wouldn't pass values to the variables, then the module will get break, and we don't want that. And in regards to locals, consider it as a constant to be honored or relied on. So let's say you have a module to create an S3 bucket. You can set up naming convention for that bucket. And that way, anyone that uses this module will be bound to this naming convention, and it will be very easy to track which buckets belong to the company or to the teams, and then it will be awesome. But also make sure that in this specific example, you need to think about limitations of the cloud that you use, if they have characters, limits, and stuff like that. And on the live side, and when I say live, I mean where we call the modules, right? Because a module is like a class, and then the live side is where you instantiate the class. So on the live side, variables, if you use them once, so just set a default, and if you use them per region, etc., use a tfvars file. And for the locals, you should try avoid using locals as much as possible because we want to keep the live side as simple as possible and leave the logic to the modules. And use data sources to pass outputs to the module because data sources allow us to grab dynamic configurations and data from the cloud. So dynamic is good. We all want to be up to date and avoid hardcode things. So if you can use that, then that's great. So the good thing about variables or locals, you should use Terraform TF-vars whenever necessary. If you have environment variables, you should utilize them because that way you avoid adding variables of your own. Use locals to hardcode one-time names and decrease code repeatability, and keep things generic as much as possible. The bad thing is that Terraform allows to set up multiple locals block, so if you don't need to, just avoid using that because it will be hard to keep track of all the locals that you have. Decentralized vars, so you can just create a variables TF file and keep all variables there, and then if you have a lot of variables, you wouldn't be it wouldn't be hard to track them all. And ignoring environment variables because then you will need to create more variables for that. And the other thing, is to hardcode values of the variables if you don't need to, because this is the meaning of the word variables, right? They should vary. So if you don't need to hardcode values, then don't do that. Okay, let's talk about files structure. So we can take example from the community standard about the file names, because as we know, Terraform just executes all files that has the suffix of TF, but we want to have a better logical arrangement and easy management of the files. Again, scaling, as much as we scale, we need the ability to do it in an easy manner. So the example from the community standard that mostly followed is the main logic is in main TF, and then we have variables, outputs, and versions. And then if we have other peripheral infrastructure that goes along with the main logic, let's say I have a module that creates a VM, then I can set up the security groups for that VM and the load balancing in separate files. And also, if you have created a complex module, you can break it down to sub-modules, and that way you can both reuse portions of that module, and also it will be easier to maintain because you wouldn't have a gigantic variable files, for example. It will be separated, and it's also good. An example for that is from the community as well. EKS module has a sub-module of creation of the node pool, and VPC module has the VPC endpoint creation sub-module. So that's a way to separate because it will be easier to maintain. Okay, we got to something that I really like, applying classic code best practices on Terraform. So I'm not saying that Terraform is a pure programming language. I think we all know that it's not, but similar rules of writing code apply to Terraform as well. And Terraform progressed over the years in a way that adapts code best practices. We can see, for example, that before Terraform 0.13, you can't even use for each for modules. And with the release of this version, HashiCorp finally introduced the ability to loop over modules with a single module call. So that's why we should apply classic code best practices on Terraform. For example, keep the code in source control management, keep the code as simple as possible. Do not repeat yourself if you don't have to. Even functional programming principles can be applied on Terraform as well, and the code should be idempotent. And in regard to human and clean, I want to quote something from an article that I will have a reference to it at the end in another slide, an article by T.C. Uo. He said, and I totally agree, that the computer that processes your code doesn't care if the variable names are ambiguous or inaccurate. If used correctly, it will still get executed, right? But since human beings are the ones to maintain this code, we need to make sure it is readable. And things like refactoring and clean code and naming conventions are invented for us human beings to read the code better, as opposed to, for the sake of us human beings and not for the sake of the computers that don't care about that. So that's why you should always try to apply classic code best practices, because it will help you in the long run when you need to scale, when you need to maintain code of others, and in general. Okay, so we talked about quick wins, we talked about second nature. Let's talk about the long haul. So we will always need to collaborate and add resources and different teams working on the same infrastructure or doing audits on that infrastructure. right? There are a lot of things that is needed for enabling your infrastructure or your teams that work with Terraform. And considering the practices that I'm going to show here will allow them to have the needed visibility on that infrastructure and isolate environments in order to scale better, and also have visibility on changes and effects, and basically just use Terraform as much as possible. So let's see which considerations they should have. But beforehand, I want to ask you one question. How do we envision the infrastructure and the company's needs? Because we need to think things through and do what's best for the company's needs and infrastructure use cases. And I want to tell you a little bit story about that. So in one of my daily meetings at work, not long ago, we talked about Presto because I work in a DevOps team for the data engineering group. And Presto is a tool to query data. And we have it installed on VMs that have auto-scaling groups. So they said, okay, let's move to Kubernetes. Well, let's install Presto on Kubernetes. And then everyone goes, yeah, let's install because we love Kubernetes. Kubernetes is a buzzword. We love, yeah. And then I thought to myself, okay, I want to work with Kubernetes because I worked with Kubernetes before. And I mean, Kubernetes is very complex, right? You can't get enough. It's not like, I'm done, no. You always learn more and more when you work with Kubernetes. And I said to myself, yeah, I want to work with Kubernetes. It's good for my career. I will have much more abilities to work in different companies. But this is not what came out from my mouth. What I said to them is, wait, we need to think about Presto. Does it work well on Kubernetes? We have use cases in production of people that are using it there. We need to think about that and not just go with the buzzwords and do whatever we want just for the sake of playing around and stuff like that. We need to think about the company's needs and the application needs. And that's why we need to think about all of these things. Also, when we work with Terraform, maybe Terraform wouldn't be like the suitable use case for you. You will need to tweak it. So only if you think things ahead and think things through, then you'll be able to really utilize Terraform in the best way possible. And let's see. Structuring your Terraform codebase. So there are a lot of ways to structure your Terraform codebase. And when we planned ahead in weeks and we really thought about what we want to achieve, we decided to use Terraform in a way in this structure that I'm gonna show you right now. So this is the structure that we selected. It's team, project, cloud provider, and region. And this is an example. So we have live and models, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. And why did we select this structure? Two reasons. First of all, Terraform as a platform. This way, all teams are onboarded and can use Terraform in the same code base repository that we have and reuse modules in that repository. And they have full independence on their code because with utilizing code owners in GitHub, they are allowed to approve their own PRs when it's under their team folder, and that's that. And that way, every team that wants to use Terraform can just add their root folder, and that's basically it. So this is one example. Another reason why we chose this structure is state files. So in this structure, the state file of Terraform is kept in US 1 for Airflow resources in US East 1 only for BI. So it's very, very small. And why is it good to have small state file? Terraform creates dependency tree for all of these resources. And if you allow huge state file, then sometimes Terraform will create invalid dependencies. And we need to help Terraform do its job sometimes. So if we have a small states setup, then the invalid dependencies probability will decrease, and then that way you wouldn't suffer from cases where you only change a tag, and then when you run Terraform plan, you'll see it's gonna destroy some resources. So we always want to avoid that. So structuring the code base in a way that will allow small state setup is very good because we want to reduce the big blast radius that could happen. Let's talk about workspaces. So workspaces isolate their unit, so you can use that for the same Terraform config for different customers, and then each customer will be a workspace on its own. And that way you reduce code repeatability because you use it once and just utilize workspaces for that. And basically coupled with that is when, let's say, all customers need to use the same financial service in a region or login service, then all of these services can be also set up in workspaces. But some notes about workspaces before you jump the gun is that you should really consider using some sort of Terraform wrapper when you use workspaces, because how do you use workspaces? With CLI, Terraform workspace select X. And if I forgot to do this select, production incident. So try to avoid that. And you have also less visibility. So if you don't use the Terraform workspace built-in variable, then you don't even know that you have workspaces. And even if you don't use that and you do Terraform workspace list in the CLI and you see a lot of workspaces, it doesn't mean that they are in use. Maybe someone just created them for test and that's that. So it's very important to know that in regards to workspaces before you just go and use workspaces for that. And just to have in check, a useful workspace usage, a very classical one, is like side branch. So if I want to test out my code, I just create a new workspace, apply it, see the syntax is okay, the infrastructure changes are good, and then I apply it on the default workspace, which is production. So the good thing about planning ahead when you structure your Terraform codebase is that it will allow you to set up small states and allow you to set up Terraform as a platform, and then a lot of people can onboard and use Terraform and basically scale your teams that use Terraform, and if you scale your teams, you scale the infrastructure as well. And the bad thing is that if you don't plan ahead, then maybe organizational changes will require to restructure your code, and you don't want that. You want to make sure that you have a full control of what's going on in your code, and also to have wrong workspaces usage could be sometimes an issue. And huge state files. So if you don't structure the code base in a way that will allow small state files, but will create a scenario of huge state files, you will definitely have invalid dependencies and big blast radius, and it's very hard to overcome this. So really try to avoid that. Okay, Terraform execution. So basically, when you run Terraform, you can run it on your machine, but in order to scale better and have one source of truth, you should run, not one source of truth, just have the ability to run in parallel. You should run Terraform in a remote manner. That way you don't have local credentials set up, you don't need local configurations, and audit, which is very, very important. So always try to aim to work with Terraform in a remote manner and avoid using it locally. Also do a Terraform apply with the plan file, that way you know exactly what gets applied, and set up Terraform timeout that is reasonable for you, because when I worked with Terraform and I tried to create an auto-scaling group with spot instances, the price wasn't right, and then I had to wait and wait and wait, and it's not nice. So just try to set up a Terraform timeout that is reasonable for you. The bad thing is to execute locally, because again, you wouldn't have audits, you will need local configurations and local credentials. And the ugly thing is to run locally and run Control-C when you run apply. I hear some laughters, then you know what I mean, but I will mention it anyway. When I just started out with Terraform, I was impatient and I had to wait, and I'm like, no, I'm not waiting. I ran Control-C, and it messed up my state. And of course, I didn't have backup back then. So treat Terraform state as the holy grail. Don't touch it. If you need to wait for a timeout, set up a timeout that makes sense, and just don't run Control-C. I don't know if they fixed this behavior by now or not, but I don't want to find out. So, okay, and the last thing that I want to cover here is practices enforcement. This is something that I had a build up through this presentation, and basically, it means that if I want to set up any guidelines or any checks to make sure that the code is in a high quality state, or have any guidelines like if someone adds resources that cost more than $10,000, then it will send an email to the FinOps team, or anything that comes to mind, you can set it up with practices enforcement. It can be done with CI pipeline stuff or GitHub actions or whatever ways that you can think about. Community models have that, as I will show in a bit, and it's good to have these practices because it will have the ability to check if the code is readable and if the resources are tagged, for example, like we do in Wix, if the code is reusable, if it's clean. So it's very good in order to keep all that in check, then you should use these enforcement. So this is an example from a community model of the Terraform AWS autoscaling. As you can see, he added checks of if the contributor formatted the code with Terraform FMT, if he added a documentation, and if you write a working code with TFLint. So this is only an example, but you can really, the possibilities are endless. You can do whatever you want in order to follow your practices in your company and best practices in general. So the good thing is to have pre-merged linters, formatters, and logical checks. As I said, you can do it with GitHub Actions or CI pipeline checks. You can set up Slackbot drift reporter to notify you if your environment is not the same as your code, but you can avoid that if you do also something that we do in Wix. We utilize Atlantis, which is an open source tool for Terraform pull request automation. So when I open a pull request, in the big background, it does the Atlantis plan. I see the plan, which is basically a Terraform plan. All looks good. Then I type Atlantis apply. Then two things happen. Both the Terraform apply happen and the code gets merged to main. And this is good because it will enforce the way that main is the actual environment. And then that way you don't have drifts. And then you don't have the Slackbot. You don't need the Slackbot. So it's very good to avoid drifts, and you can do it with Atlantis or any other way that you think of. And the bad and the ugly here is not about practice enforcement, but if you don't use practice enforcement, then you could potentially face security issues and a non-compliant configuration that will be in your code. And on the right, you can see some open source enforcement and helpers that will help you in your journey of introducing practices enforcement in your Terraform code. Okay, so we had a question, right? How do we envision the company needs and the infrastructure needs? And I hope that after I talked some about the Terraform practices, you had some things come in mind about, yeah, we need to do this, we need to do that, and stuff like that. And you can say now that this is how we envision the infrastructure the company needs. And if you don't, then that's okay, but just, again, wait, think about it some more, and then go right ahead and plan and implement things as you see fit. So I don't know if this is big enough, you tell me, but this is what I want you to take out of this presentation. So code-based structure will allow you to set up Terraform as a platform and set up small state files. And if you set up practices enforcement, then it will help enable infrastructure and team scaling. And basically, if you are the one to maintain Terraform and provide it to other teams as the platform, then you basically help others help you, which is always awesome. And always, like any other tool, don't use Terraform in an ad hoc mindset. Plan for your future needs. And I want to quote something else from the article that I mentioned before by Thyssen Ur. He said, and I totally agree, that programs evolve and code changes. And it's really uncommon to write Terraform code that stays the same, right? Because if everyone would do it, then I wouldn't even be standing here and talking about Terraform practices because everyone will just use it in the same way. But this is not how projects work. And we want to have projects, right? Because what is a project? Move from one state to a desired state. This is a project. And companies and businesses want to improve. And we want to allow companies to introduce projects in the day-to-day. So in order to do that, we need to think about how we structure the Terraform code base and how we treat Terraform generally. And that way we will allow projects to evolve and get introduced and help the company improve and contribute to the company's success and eventually your success. And basically allow you the ability to enable infrastructure scaling and your team scaling as well. So these are some references that I mentioned throughout my talk about labeling, about workspaces, things that needs to be considered. The DCN Guru blog post, which is very good. I really recommend reading it. And about the practice enforcement, you can either use TF-lint, or there's also a bundle called SuperLinter in GitHub. Then you can set it up as a GitHub action, and out of the box you will have great checks in your repository. That's it. I hope that you enjoyed my talk. I know that I spoke quickly at times, but because I had a lot of things to cover. So if you have any questions, I will be just right outside. And that's it. Thank you so much.